Hi, everybody. This is Carl Freund with Cambridge AI Research. And once again, I've got a pretty special guest today, uh, world famous chip designer, Jim Keller, joining us from Tenstorrent. Welcome, Jim.
Hey, thanks for having me.
You must get tired of people always saying that, right?
Well,
World famous chip designer.
I
Right?
know.
You
I know. So I have two teenage girls and they think it's hilarious. And I attempt to troll them, but they're like, yeah, Dad, we know you better. Like, there's no problem. But it's a surprise to me, to be honest. I like to build chips and I like to think about what's going on and what's happening. And then I talk about it with friends and my partners at work. And I also do it publicly. And then people give me lots of feedback. And it's interesting.
Yeah.
That sort of combined somehow unintentionally, I promise you, to be something different than that. So.
Well, you're working on some very interesting silicon there at Tenstorrent. Why don't we start with a high level for those of my audience that are not familiar with Tenstorrent? I'll just give them a brief overview of what the company's about and what it is that brought you to the helm as a CEO.
Sure. So Tenstorrent was started as an AI company, and it started as a classic garage shop, three guys in a basement for a year and a half, working on solving the AI problem. And it's a curiously difficult problem because if you look at modern models, you think, oh, this PyTorch program, which is sort of Python with matrix multiply calls in it, looks pretty straightforward. But then it turns out to do that performantly, efficiently, reliably, the compiler is difficult, let's say. And, and many people have started with, well, how hard can a matrix multiply be? And, a couple of years later, after spending lots of money, they're like, this is a really hard problem. And it's rooted in a classic HPC problem of parallelizing code across many processors, let's say. And that problem's been difficult for a very long time. And so I joined Tenstorrent. I was one of the original funders. I was the angel investor way back when. I joined 2 years ago when we were getting ready to ship products. We had software coming up on our first gen product. Our Gen 2 product came back and powered on about 2 years ago. And that was pretty solid. And then we start working on going to market, and we ran into the wall people run into, which is you get a couple, your hand coded stuff looks great, right? You wouldn't get funded if you couldn't do that. Then you start building more models, and then you elaborate your compiler stack and your software stack. And initially you make great progress, and then you stall. And then we did, let's say, 2 full rewrites, and that's hard to do. And we're not the only ones in the boat. And one of Labija and my commitment was we wanted to build AI hardware software stack where you could write AI code and compile it and get good performance pretty naturally. And as opposed to only having a low-level software stack that many people have to write lots and lots of hand-coded code to make it performant, which, by the way, is a path, and that's essentially the one that's enabled NVIDIA. They have, literally thousands of people doing low-level programming. So it's a path. We've been working on trying to build a more automated software stack, and we're starting to have some success with that. We have a very good software team, and we're cracking that problem. Cool. And then the second piece was I believe that AI computing and general purpose computing are going to collaborate together. That there's a swing going on that, AI was nothing, and then it's like 10-20% of the data center. I believe it's on its way to 70 to 90% of the data center. Wow. Either in terms of dollars or cycles or applications. Like, it's happening pretty fast.
Yeah.
That doesn't mean there's not going to be another break in the hype cycle. Like ChatGPT is, everybody knows about it. I get pinged by all kinds of people. What do you think about ChatGPT? And I think it's great, but the hype cycle will be over, I think, in September, predicting. Well, we'll see what happens. But the trend towards AI kind of computation is real, and then the collaboration between AI compute and general purpose compute is real. And we started a CPU team because we wanted to build the right CPU to go with the AI processor. And for lots of weird reasons, like ARM wouldn't support the data types we wanted. We couldn't make the modifications we wanted because it's of ARM license restrictions. And, everybody's talking about ARM's business model has changed in a way that's caused a whole bunch of people to think RISC-V is a better alternative. But for us, it was fundamentally technical. Like, I want to be able to add the data types I want as soon as I need them. I want to be able to build the AI processor and the CPU to talk to each other the way I want to. And I couldn't do that with ARM, to be honest. And so we built a CPU team. And then the surprise was how much interest there was in RISC-V.
Yeah.
We
It really
started
has.
talking.
It's
Yeah.
it's really exploded in interest just in the last year.
Yeah, for a bunch of reasons, technical reasons, business reasons. And also there's a critical mass kind of thing going on where, well, like a year ago, people said, well, how am I going to run my software? And now everybody knows the RISC-V software ecosystem is pretty good, getting better pretty fast. So it's hit critical mass. And then there's an open source component too. Like open source is a one-way door. Like when people move from proprietary operating systems to open source, they didn't go back. When they went from proprietary web development kits and databases to open source, it mostly didn't go back. Being able to own your own technology and drive it is really interesting. And I think there's more room to move. And I've been talking with Raja Gaduri, who's a longtime friend and collaborator of mine, about, well, if we had an open source CPU and an open source GPU and an open source AI architecture definition, what would the world look like?
That'd be interesting. Yeah.
Because then you could build a whole bunch of products and then and move. Proprietary is cool because you can build a great thing and focus all your energy on it. The problem, the customer has 10 other ways to use it, and proprietary solutions just don't have the reach. Right? You can't make the modifications you want. Possibly you can't make the money you want to make.
I was going to ask, how do you monetize something like that?
Well, here's the good news. I'm a little startup, like I'll die and go to heaven when I have 100 million in revenue and growing. I don't have to make $8 billion anytime soon. So, but it is a big question. Now, Red Hat sold for $33 billion or so on open source software. So monetizing open source is a thing, but you have to really solve customer problems. So if you have a proprietary monopoly solution that people can only get from you, you have a lot of pricing power, let's say, but you've also encouraged people to look for alternatives.
Right.
In an open source world, people say, well, I could, like people told us, like, Jim, I like RISC-V, I like the software story, but I don't want to call the internet if I have a compiler problem. I want to call you. So I hired one of the best, open source guys I know, Olaf Johansson, and he's helping build our open source team to basically support all the RISC-V software tools, operating system compilers, which doesn't mean we're going to do all the work. But if somebody, buys something from us and then they have a problem, they'll call us and we'll get the right answer for them pretty fast.
So help me clear up some confusion when I talk to potential investors about TensorFlow. They're a little confused. All right, you're an AI company, are you a RISC-V company, or are you both? Why don't you talk to that for a moment?
Yeah, so it was we're an AI company. We're going to sell a chip on a board and possibly in a server. And then we started going to the market and we found out some people want chips, some people want boards, some people want servers, some people want cloud, some people want IP. And the reason is they all have their different solutions they want. And then we built a CPU, which was going to work with the AI to make a better AI solution. And some people said, forget the AI, we want the CPU, right? And the CPU engagements to date have been more about IP and chiplets than like final solutions, because they're like, well, I'm building this solution and I need a really fast CPU. And then the question is, if I have IP, I integrate it in my chip. If I have a chiplet, I can put that on a package with my solution, but then I get what I want, right?
Yeah.
And then I realized, like, we're really a design company. So I have really good AI engineers, I have software guys, I have cloud software people, I have a CPU team. And when we talk to people, it's like, well, we're building these technologies and you guys have a problem. what do you want me to do so I can help you solve your problem in a way that we get paid and you're happy?
Mhm.
Or a design company, I would say.
That's an interesting,
With
interesting.
a belief that AI will dominate silicon and compute,
Mhm.
let's say.
Mhm.
So, like I tell the team, it's like in the short run, we can monetize CPUs faster because it's well understood. And the transition from like x86 and ARM to RISC-V is real and happening. Long run, the TAM and AI is bigger.
Hmm.
And you know, it's a little complicated, but it's not that complicated. I don't think it should be confusing. And
Yeah.
the interest is really high, and that's kind of what I've been focused on recently is like, how do we make technical progress on what we want, talk to people who want to buy, you know, this technology and like build their own solutions, and then, you know, make sure we actually can support the people that, you know, work with us.
Right.
And
So what do you think is the biggest challenge in building effective AI, especially in the age of generative AI?
well, you know, you can read about this in the funny papers. Everybody's like, these language models are unbelievable, and ChatGPT is great. And if it really takes off, we'll be bankrupt because it's too expensive. So on the AI front, like, how do we deploy at scale at way better costs?
Mhm.
And then how do we build the products? Like, there's so many different products, you know, there's obviously the big training solutions, the big inference solutions, but there's edge computing, autonomous driving, robotics. Enterprises all over the place have told us our AI problem's not that big, but it's real,
Mhm.
right? Like a large percentage of enterprise inference is run on CPUs really inefficiently, you know, but they don't have a cost-effective solution in that space.
Mhm.
So there's a whole bunch of market niches. There's a whole bunch of things. There's a huge driver on cost and power, obviously. And then the thing we're tangling with is how do we build an AI solution that you can start to really treat as a compute engine that you compile software for and get reasonable results? Or if you're a black hat and you want to hand code it, how do you hand code down to the metal and get every last drop of performance out of the silicon in front of you? So
Mhm.
that's the AI challenge that we're working on now. And like I said, we're making reasonable progress, and it's been tough, but
Yeah.
we're getting there.
So with the explosion in transformers, the surge in interest, how does your design match up to that? Because you're using GDDR4, right? Not
Yeah.
HB.
Yeah, no, our Gen 1 part. So first, there's a really big spread. So people come to us and say, how do you compete with the H100 at $32,000? Well, I say, well, I got a part that's 20% as fast for $1,000. And they go, oh, wow, that's really interesting. So our Gen 1 part is a pretty good performer. It's a PCI Express card. It's easy to plug in. It's very competitive with the low end of NVIDIA's product line at a better price. Our Gen 2 part is GDDR5. It's not HBM. It's 100 gigabit Ethernet. And here was a business decision we made a couple of years ago, which is let's live in the consumer GPU cost infrastructure. And that means like a GPU package, GPU DRAMs, simple boards, Ethernet, not InfiniBand, GDDR5, next gen is Gen 6, not HBM. And the reason for that is for AI to hit the cost points everybody wants to deploy at, it can't cost $2,000 for a package and $2,000 for DRAMs and $1,000 for a die and an extra $500 for a cooling solution. Like, you need to live in the cost structure of the target that you're aiming at, right? And so we made decisions like that, which means no, we don't have 3 terabytes of DRAM bandwidth. We built an AI processor that uses much less memory bandwidth than a GPU.
Mhm.
And we built it in a cost infrastructure that makes sense. We actually last year wasted a whole bunch of time trying to design an HBM solution. And we just couldn't see a path to getting a reasonable cost infrastructure on it.
Yeah.
There's some interesting things happening with packaging. And maybe in the near future, but packaging is one of those things that, you know, you really see it go it needs to go into a certain amount of volume to really hit its cost, potential. And there's a lot of efforts on that, and I'm pretty interested. And when it happens, we're going to move fast to it, but it's not happening that fast. And so if you want a cost-effective solution, you have to think about it. And the interesting thing is consumer GPU packaged DRAM infrastructure isn't cheap in principle. It's cheap because they spent billions of dollars over 10 years or more refining it, improving it, speeding it up. Like GDR6 is over 20 gigabits a second on per pin, which is amazing. Like you look at the technology, you go, well, how'd they do that? Well, they did a lot of work. But the truth is, you could buy those DRAMs and the PHYs and the boards and put them together, and they work pretty good. Like
You get the benefit of a volume, right?
Yeah. Volume and a lot of hard engineering work.
Yeah.
Like every once in a while, you just go, well, the HBM and the GDR6, they're both really interesting. One of them's been shipping in really high volume, really aiming at low cost for a long time, and the other is up until, to be honest, up until the A100 happened, it was more of a niche DRAM product, but it's never been driven for cost.
No, I don't see that changing anytime soon either. So where will Tenstorrent be, let's say in 5 years? What in terms of we're going to focus data center versus CPUs? Please excuse me.
Well, I would like to sell our technology to people who want to buy it to go solve their problems.
Yeah.
And that's the mode we're in right now. Like, and we talk to lots of different people. Like many people come to us and say, we can't solve our problems the way we want. Like the NVIDIA solution is too expensive, or it's designed for a high power data center kind of product. You can't put a 400-watt card really in a car.
Yeah.
One guy said, Jim, we can't put a $10,000 GPU in a $10,000 robot. It just doesn't make any sense. So there's a whole bunch of places in the world where access to technology is important. Being able to make a decision like, should I buy a chip or buy a chiplet, or I'm working with these guys that are going to build a high volume ASIC, but they need so much AI performance, and they want a compiler that they think works. And this is where the open source kind of plays. Like our intention when we sort out our compiler is to open source our compiler software stack so people can see it. And then if they decide to buy it and invest a whole bunch of time and effort, it's not like somebody can take it away from them. Like the genius of, Intel was the original open source company. People don't remember this. There was 6 or 7 sub-licensees of the x86 architecture. That's one of the reasons it won over the Z80 and the 6502 and the 6800. It was the open source world. And then obviously Microsoft was proprietary, but when Linux came out, there was a half a dozen very mature proprietary operating systems, and Linux replaced all of them. And so in 5 years, I'd like to be successfully participating in the open source world of RISC-V across CPU, AI, and GPUs. And, build a successful business, kind of more in the solution space than, we're the solution for this particular niche.
Yeah. Okay. Interesting. Well, we wish you all the luck in the world, Jim. It'd be fun to watch you guide this. I think one of the challenges is, as a startup in the now chiplet world, you can go so many different directions, and it's really interesting to see, where you focus and just knock it out of the park.
Yeah, thanks. The chiplet stuff is really interesting. We talked to over a dozen people making chiplets, and there's sort of it's creative tension world, right? One is lots of people are doing all kinds of different things, so maybe it'll never work together. On the flip side, everybody realizes that if we make a set of chips work together properly, then they can build all kinds of different products, and potentially at a huge savings on tape-out costs and IP licensing costs, because now you can source chiplets for a couple different things and make a product pretty fast. So this kind of stuff has been, I don't think the technology in terms of packaging and die-to-die-fi and stuff has been mature enough before to create this opportunity. So I'm optimistic about it, but it's definitely fraught with, let's say, diversions.
Yeah, a lot of challenges putting somebody else's chiplet into your chip. And what's the governance like? What's the security like?
Gen 1 is definitely going to be partners co-simulating together and, let's say, cooperating.
Okay.
And there's a bunch of people who want to do that, and we're open to. Somebody said, hey, I have this great solution, I really wish I had a partner I could build an AI chip or a CPU chip, or we're doing a few other things as well that we'd be happy to chat about.
Sounds good. Well, let's stay close and enjoy working with you and your team. And I think you're going to have a lot of interesting things to talk about in the next couple of years. I look forward to having you back soon.
Okay, great. Good to see you again today.
Good to see you again, Jim. Take care. Bye-bye.